Let's get ready to start section 4.5. We're probably going to soon start having questions about the final exam. I'll put comments on D2L in the next, by the end of this week or early next week, start helping you get ready for the final exam. As you know, it's going to be almost all, well, it's all chapter 4 and that little bit of chapter 5 we're covering. So no real surprises. As always, I hope you printed out assignment 4. And as we're going through this material, you're doing those problems. You're not going to wait till the night before and try to get them all done. But anyhow, okay, moving on. Today, we're going to get ready to start section 4.5. I'm going to do this. 3 to the x equals 3 squared. What is x?
X equal to 2.
2. Yep. 3 to the x equals 9. What is x?
Again, x equal to
Yeah, it's going to be 2 because that's 3 squared, right? Yeah. Again, it's going to be 2. 3 to the x
equal to
equals 81. X equals
4.
4. Yeah. So as long as the bases are the same, I'm allowed to set the exponents equal to each other. X would in fact equal 4. All right. So that's going to be a starting building block for what we're going to do today. If I can get the bases the same, the exponents can be set equal to each other. This guy, 5 to the 3x minus 1 equals 5 to the 5 times 5 times 5 cubed. Calculate x. This is what we're doing, what you see up here. The bases are the same, the exponents equal to each other. So today in this section 4.5, as you can see, we're going to work with a bunch of equations. Those equations are going to involve exponents and logs. 3x minus 1 equals 3. X equals 4/3.
4/3.
4/3. Very good. Okay. This guy is 4 to the negative 1, or 2 squared to the negative 1, or 2 to the negative 2. And some of you may be going, oh yeah, now I remember that. That's good. Some of you knew it right up front. That's better. But if you weren't sure, okay, 8 is 2 cubed to the x, and my rule of exponents say I would multiply those just like I did here. Okay, negative 2/3 equals x. Nice. Nice, baby. Dun, 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 dun. Oh. Try 3. I'll give you a second or two to try 3. Can I get the bases the same? That's my first question. Can I get the bases to be the same? Ice, baby. I got 3x plus 9 equals 10 minus 4x. 8 is 2 cubed. I multiply exponents, that whole power thing. 4 is 2 squared. I multiply exponents. Add 4x, subtract 9, x equals 1/7. Some of you are going, woohoo, I got that. You're so excited, you're going to put a check mark up with your name. That's how excited you are. Uh-oh, somebody else snuck in. Who came in? Who's here?
I joined late.
Who was that? Kaylin? Because she put, oh, she has a check mark because she got it. Who's I?
Ryan.
I'm old. Welcome to the show. Welcome to the big show. Okay, any questions on those first three? If not, we're going to get ready and move on. All of a sudden, I get number 4, and it says 2 to the x equals 7, and I said 7 is a base. 7 is a prime number. I can't break it down any farther. So now I have a problem. Well, let's use some of our prior knowledge to see if we can solve this. Well, that's an exponent. I can rewrite this as a log. This is log base 2. Remember, that's like the base of my exponent. That's why we say log base 2 of 7 equals x. And I get a whoop, whoop, because I know how to do this. The very last thing I learned was called the base change or change of base. I can rewrite log base 2 of 7 as the log of 7 divided by the log of 2. And remember, these were called common logs. Common logs. And then if I grab my trusty calculator, I hit clear and I can go log of 7 and I get that value. And then I'm going to divide it by the log of 2 and I get the value 2.807 equals 2.807. Well, if you think about it, 2 squared is 4, 2 cubed is 8. So yeah, my answer should be kind of close to 3. I like it. I love it. Questions? Questions?
In this, we can also put log in both sides, right?
Up here
Yes.
or here?
Log, yeah,
Here I
log
can
2.
put log. Exactly. Excellent. If I have this to start, I can log both sides. 2 to the x equals log of 7. By my power rule, the x comes to the front. And then I divide by log 2. And that's where that base change rule comes into play. Right there it is.
I
Okay.
like this way.
Yep, that's where that comes into play. It's a good review of that. All right, all right, all right. Problems 6, 7, and 8. I'm going to pause the recording. I am going to, okay, so you had time to work on them. Hopefully, I don't mess any of these up. I'm going to zoom in a little bit. Log base 3 of 0.07 equals negative 0.02x. This is my base, log base 3 of that. So this is the same as log of 0.07 divided by log of 3. And if I do that on the calculator, I'm going to do log of 0.07. I get its value. I'm going to divide by log of 3, and I get its value, negative 2.421. Negative 2.421 equals negative 0.02x. So now I'm going to divide by negative 0.02. So I'm going to hit divide, and it's going to bring that previous answer up. Negative 0. That wasn't negative. Negative 0.02. And I get 121.028. Can I get a thumbs up? Can I get a check mark? Can I get a woo-hoo? Did anyone get the same thing? Okay, I got a nod from Nina. Thank you, Nina. Let's see. This last problem and the problem before, I had the base alone. Reminds me of the absolute values and square roots. I needed to get those alone. I'm going to subtract 4. I'm going to divide by 3. Now I have that exponent alone. Log of E, base E of 7/3 equals 2x. Log base B, E of 7/3 equals 2x. So that's going to be the log of 7/3 divided by the log of E equals 2x. Hopefully somebody got to work on this, or you're still working on it. You're just barely ahead of me. So I got an answer. I divided it by the log of second natural log. And when I do E, I always have to put in a power. .847. 0.847. And then I'm going to divide that by 2. 0.424. Oh, I got a little off screen there. I subtracted 4, divided by 3, log base E of 7/3 equals 2x. Log of 7/3 over log of E. I calculated that. I divided by 2, and I like 0.424. All right, number 8, craziness is going to ensue. So hopefully you at least have the problem written down. And this isn't like the last 3 problems because I have bases on both sides. And I don't really know what to do with either of them at this point. So I'm just going to start out by saying, hey, I can log both sides. Trick I learned a little while ago. Log base 10, 2 to the 3x minus 2 equals log 3, 2x plus 1. And I've learned before I can bring those exponents around. Power rule, 3x minus 2 times the log of 2 equals 2x plus 1 times the log of 3. Okay. The log of 2. Oh, no, I don't know what I just did there. Log of 2 is a number, 0.301. So this becomes 3x minus 2 times 0.301. On the right side, I get 2x plus 1 times log of 3.477. Heck, you're good there. You're good now. This is just algebra. Distribute, solve for x. How did I start this guy? I took the log of both sides, which allows me to bring those exponents for both of them around front. Up here, I only needed to take the log of one of them, but I didn't really need to do log because I changed the the log into an exponent. So now I have some algebra work. Distribute, combine, dotty. 0.903 x minus 0.602 equals, if I distribute the 0.954 x plus 0.477. Yeah, you learned about working with decimals back in Algebra 1, and maybe even pre-algebra, you did some of this stuff. That was a building block for today. Let's see, this one's bigger, so I'm going to send that over and subtract 903 from 954.051x. I'm going to subtract over here, so then I'm going to get negative, let's see, 0.602 and 0.477 gives me the negative 1.079. Now, hopefully on a test, you don't have all of this. You need to be tested on what's up here, not screwing something up from what you've learned before, but it's possible. Divided by 0.051, 21.157. Unless I mess something up. Yeah. Okay. Again, two different problems. Up here, I only needed, I only had one exponent. So I changed this exponential into a logarithmic. Down here, I had two exponents. So my next strategy was to take the log of both sides. Up here, could I have taken the log of both sides to start? Yep. Yep. But by changing it with my log rule, I got to where I wanted to a little quicker. All right, not so bad. Not so bad. Oh, they're sticking. There we go. Oh, man. Quadratic in form. Yeah, that's a quadratic. And I can start this bad boy out. So some of you are going on to these other partner disciplines or sister disciplines where you're going to get crazy equations like this, and you have to know how to solve them. This is one where I'm going to say, I'm going to do a substitution, and I'm going to let W temporarily equal e to the x. In doing so, I get W squared minus 8W plus 12 equals 0. Do, 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 do. Okay, this becomes W minus 6, W minus 2, W minus 6 equals 0, W equals 6, and by the same process, W equals 2. So I come over here, and now I'm going to substitute back. That's not so bad. All of this is algebra from before, right? How to factor. I needed the trick of the substitution. That's okay, Kaylin. No problem. And again, how do I solve this? Log base E of 6 equals x. Log base E of 2 equals x. Oh, I know what log base E is. That's my natural log. That's natural log of 6, natural log of 2. Throw those bad boys into the calculator to get your answers. And that button was there. It's underneath the log. Log of 6 is 1.792. And the natural log of 2 is 0.693. All right, so we know this section was called equations with logs and exponents. And all of a sudden I have some, okay, I have some craziness down here. And what's going on? This guy down here is kind of what I want. If the log and the bases are the same, what's beside them is equal to each other. If the log and the base are the same, I can basically drop it. But you notice it's a side, the log of a side and the log of a side. Not like up here. These are individual ones. These are individual ones. So I can't just do that. I need the log of side. The word side should be in here somewhere. So when I get ready to do number 10, I'm going, whoop, whoop. I have the log of a side. And the bases are the same. So I can just set those equal to each other. Nicely done, sir. Thank you. Thank you very much. I'm going to subtract 2x. I'm going to add 1. I get x equals 6. If I plugged it back in, both of these would be 29. Easy peasy. What's the rest of it? Easy peasy. Lemon squeezy. Okay, Jesse, I have one for you. What is it? Red Robin.
Yum.
Thank you. That's the Sheldon in me come out from Big Bang. Hopefully, yeah, somebody will answer that for me. 11. The logs of the side and the log of a side, the logs are gone. I'm going to add an x. I'm going to add 7. So I'm thinking, wait a minute. Why is the problems both so simple? Why are these both so simple? Well, 11 is special because if I went and checked my work, I would in fact have the log of -1 equals the log of -1. Can't say it. There it is. The log of -1. Well, one of the things I have to remember is my log graph looks like this. We didn't do a lot with that. Okay, my exponential graph looked like this. We talked about them being symmetrical over the line y equals x and so forth and so forth. And I come up to a domain problem. I am never allowed to take the log of a negative number. So this guy, no solution. So if you're ever checking your answer and you get something wrong, you're like, I know it's 6, and you just threw your calculator against the wall and you plugged it back in, and all of a sudden you saw, oh, that's the log of -1. That's why my log can never be negative. So don't try to put that in your calculator. It's not going to work. Okay, we're really crooked right now from when I banged it earlier. 12 and 13. I do not have the log of a side, but the rules I learned the other day tells me I can combine these. We even started today with one of something like this. I can combine, and on my left side, I'm going to get 3x minus 4 over x plus 1. That was my quotient rule. Nice. Now I can drop the logs. 3x minus 4 over x plus 1 equals 2. Same over here. This becomes the natural log of x plus 3 times x. That goes back to that simple rule. Nice. I'm now at an algebra problem over here. Okay, and if I run through it, I have 3x minus 4 equals 2x plus 2. Subtract that, I get x. Add that, I get 4. Boy, this author really likes the answer 6. And if I go back up here, that's a positive, that's a positive. I'm all good. No mess ups like 11 where in my answer I'm trying to take a negative. Do 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 do. This guy becomes the natural log of x squared plus 3x equals natural log of 10. I drop them because I have of a side. And subtract 10. X plus 5, x minus 2, x equals negative 5 and 2. And I need to check my answers. When I put negative 5 in that first one, I end up with natural log. Nope. Negative 5 is not going to work. 2, that gives me a positive 5, a positive. Yeah, I'm okay with 2. I am not okay with negative 5. So warning, Will Robinson, danger. Anybody know who Will Robinson is? Okay. There was a show called Lost in Space. Questions? Y'all really quiet today. Okay. Oh boy. 14. 14. I'm going to pause it, give you about 2 minutes to work on that on your own first, so that I'm not doing all the talking, you're doing some work. Okay, so again, I brought that power up and made it x squared. My rule of logs, this becomes the product for a single log. Left side is going to be x squared equals 6x minus 8. X squared minus 6x plus 8 equals 0. X minus 2, x minus 4. I get x equals 2 and 4. I quickly want to check, would there be any problems? If I put in 2, that's okay. That's okay. If I put in 4, that's, yep, they're both okay this time. I plugged them back in and they both worked well. This is that ice cold. Okay, more equations. 15, 16, 17. We've been doing a bunch of this already. We've been rewriting log base b of x equals k as b to the k equals x. Okay, b to the k equals x. So I'm going to give you some time, let you work on 15, 16, and 17 and see what you can come up with for those. I'd love to be able to put you in groups. So I have a couple guesses at answers. 8 and 8/3. Again, I'm going to write this as my base, my exponent. 5 squared equals 3x plus 1. 25 equals 3x plus 1. 24 equals, I get 8. I have 8. Did I do anything wrong? 5 squared is 3x plus 1. Subtract 1, divide by 3, I got 8. I think it's 8. So 15 was nice. It was nice and clean. 16 is not clean. If I could make it look like 15, that would be great. 15 was a single log, so I'm going to come over here and say, ooh, I want to make that a single log. Log base 3 of x plus 6 over x minus 2, 2 equals 2. That was my quotient. My quotient is the log of the numerator minus the log of the denominator. So we started with those today. We started with these 3 today. We're going back and forth and back and forth. I just looked at a difference of logs is the quotient. The sum of logs was the product. Oh, 3 squared equals x plus 6 over x minus 2. So all we're really learning today is how to change these equations into something algebraically I can work with pretty quick. 9 equals x plus 6 over x minus 2. 9x minus 18 equals x plus 6. Yeah. 8x equals 24. X equals 3. I like it. I love it. So I made it look like that. I got it to be a single log. Well, this one looks different than the last one because I have a log on one side and a log on the other side. And I'm saying to myself, is there any reason I can't get them on the same side? And myself says, sure. I'm going to add log of x. This is the sum of logs, which is going to equal the product. X plus 5 times x.
It's x plus 15.
Oh, thank you, thank you, thank you. Thank you, thank you. This becomes log of x squared plus 15x equals 2. That's my common log. That's my common log. That means I have a log base 10. 10 to the second power equals x squared plus 15x. 10 is 100. And then I'm going to subtract it. X squared plus 15x minus 100. Oh boy. X plus minus. X plus 20, x minus 5. Factoring is our specialty. Working with the logs, I know I can't take the log of a negative, and right away I look at negative 20 and say, ooh, if I tried, yeah, no, not going to work. Log of 5, I plug that in, That's a 20, that's okay. That's a +5, that's okay. I'm okay with just the answer, x equals 5.
Where did you get the 10 square? from?
Okay, so down here, this guy is called the common log. He is base 10.
Okay,
Yeah, so if it's not written, it's assumed to be base 10.
10, okay.
So now I did the 10 squared equals that. What do you think? I just made that up. I like it. Please tell me there's only one more page. Okay, there's only one more page. I think I need to get the logs on one side and then that 3 on the other side. Okay, so log base 4 of x squared minus 9 minus the log base 4 of x plus 3. Then I'm going to send that -3 over there. Okay, I like that a little bit. Log base 4 of x squared minus 9 over x plus 3 equals 3. Let's see. 4 to the 3rd power equals x squared minus 9 over x plus 3. And we all know what 4 cubed is. X squared minus 9 over x plus 3 equals 64. Oh boy. X squared minus 9 equals 64x plus 192. What a mess.
Can't we factorize x square minus 9?
What would you like to do? Go ahead. What would you like to do to it?
Yeah, just factorize x square minus 9 to x plus 9, x plus 3, x minus 3.
We absolutely can. And here's what Radhika is saying. Can we make this x plus 3, x minus 3 over x plus 3, and then cancel? And we can. And in doing so, we get x minus 3 equals 64 or x equals 67.
Yeah.
Now, if you are not sure, what you would need to do is keep going with this. So you did that and everything looks good, but wait a minute. One of the things I just picked up was when I write it like this, x cannot be -3. And if I come over here and plug -3 in, I'm going, oh, that gives me 0. I can't take the log of 0. Again, a log looks like that. It's in the 1st and 4th quadrants. Yeah, okay. And had I kept going here, I'd have x squared minus 64x minus 201. And then I'd have to factor and I'd be crying at this point. But thank you to Radhika, she saved us a little bit of work. And what does this factor into? Check it out. X minus 67, x plus 3. And then I would get -3, which we already eliminated. and I would get positive 67, which is what we have there. So it all works out in the end. Okay, let's try 19. There's a 20. Think if we can get through 19, we're good for today. We're good for today. Let's see, I'm gonna go back to some of that financial stuff. And, you know, if we were working and, you know, I'm like, yeah, I want to go back to that. If Joe has $10,000 and it's at 8%, you know, which is 0.08, and it was for 4 years, we had come up with an equation of 10,000 times 1 plus 0.8 to the 4th power. That came from 10,000, 1 plus 0.08 to that. That was my adding 8% of the new amount every year. You might want to go back and brush up on that. Looks kind of familiar. And then we had a second, instead of yearly, what if it was monthly? We had 10,000, 1 plus. If it was monthly, that means it's only a 12th of that. And if it was monthly, it was, you know, over 4 years, it would be 48 months. So we had an equation that looked like that when it was monthly. And then finally, we had an equation that was written like this, PERT. And that's when this 12 would get bigger. Instead of monthly, if it was daily, it would be 365. If it was minutely, it would be, if it was second. And as that 12 number got larger and larger and larger, we were able to convert it into this. So it would have been 10,000 e to the rate 0.08 to that time, which was 4 years. And this was continuous growth. And again, we didn't do a lot with that, and it's a great formula and it's good to work with. But this is what we had, 10,000, 8%, 4 years. And if I calculated it at the end of the year, I'd be doing it 4 times. Okay. If I calculated it monthly, I'd be doing it 48 times. And then we had continuously. If I come back over here, again, it's compounded continuously. So this is the formula. My amount is going to be my principal times e raised to the rate times time. How long would it take your money to grow to 45? I'd like to have $45,000. So my A is going to be $45,000. My principal, what I started with, $20,000 times e raised to the rate 0.025 times the time, which is t, which is what I need to solve. This is the amount I wanted to end up with. This is the amount I started with. It's being compounded continuously, so I use this formula. E to the rate, 2.5% is 0.025. T is time. How long would it take for that to happen? I'm going to pause the recording. I'm going to divide by 20,000. I'm going to end up with 45,000 over 20,000. I know all those zeros can go. And I can divide by 5. That's 9/4. That's 2 1/4. 2.25 is what I ended up with on the right side. Equals e to the 0.025t. It's kind of what I've been doing, right? I'm gonna take the log of both sides. E is my base. Log base E of 2.25 equals 0.025 t. And I know log base E is my natural log. So now I want the natural log of 2.25. Natural log of 2.25. I get 0.811, 0.811.025 t. And I'm going to take that answer and divide it by 0.025. I took that answer, divided it by that, and I got time equals 32.437 years. We all have $20,000 laying around that we can invest it so it becomes a whopping 45,000 in 32 years. That answer is, so, you know, that's a legitimate answer, 32. That wasn't 6,000 years. It wasn't 0.4 years. So a little estimation, common sensible skills come into play there. All right, any questions? Any questions? Okay, we have